if you are a homeowner and you're trying to install a generator, this video is for you. If you're an electrician and you have a job where you need to install a generator and you have no idea what's going on, this video is for you. I had a really cool opportunity recently to watch some other electricians install a generator. I was in Chicago and I don't have a license in Chicago, so I couldn't do any work in Chicago, but I thought it was a really good opportunity to like just talk about generators and show people how they're installed and then talk about how they work, because there's a lot of like, you know, low voltage conductors and there's some power conductors, there's transfer switches, automatic, you know, manual. So I thought this would be just a good opportunity to like talk about generators as a whole. All right, now before we get into the actual install and talking about how these systems should be installed, let's do a kind of an overview of 30,000 foot, like what the system looks like and how it functions as a whole. So typically when we walk into an environment where we're going to install a generator, we're going to be going to the service and we are going to have a meter that is getting fed utility power, and we're either going to have a main disconnect or we're going to have a main service panel. We have to interrupt this connection right here. We have to cut this and either move these apart and put a transfer switch in, or we got to put a transfer switch over here and like reroute the incoming power to the transfer switch first and then refeed the panel. But that transfer switch has to interrupt. We have to come from utility power to the transfer switch to the panel if we're doing a whole home generator install. So inside of these generators, a lot of times they're service rated, which they come from the manufacturer as service equipment. So we can use them as our first means of disconnection on a house. So we can do all of our grounding and bonding, grounding electrodes, grounding electrode conductors, equipment grounding conductors, neutrals, all the stuff bonded together at this single point, because now this becomes the service. You can have a manual transfer switch where you have to actually go out and pull a handle to try to engage and change it from utility power to generator, or you can have an automatic transfer switch which uses logic and it monitors the phase conductors from the utility, and when there's power lost, it automatically switches over, starts the generator, and takes care of everything within usually like a minute. So that's the transfer switch portion of the install. Let's look at the generator itself. So generators kind of like, there's a lot of them that are different, but like there's a few things that they have in common. So the generator that you're about to see put in is a single phase generator. It's 22 kW, so that's a pretty massive capacity that you can have on a house. Generators are going to have a battery, so there's going to be a 12 volts, usually around 650 cold cranking amps, so a car battery really, to be able to provide this with starting means, because you have to have some kind of ignition source to be able to start the motor, just like your car does. Generators need some kind of a fuel source, so whether or not you're going to dig in a massive propane tank in the ground before you put this in to provide propane, gasoline for the combustion, or if you have natural gas already on your property, so if you can pipe in, like at this house, there's actually natural gas there, so they just extended a pipe over and hooked it up. So it's like utility provided gas, right? So there's not constantly having to have a truck come out and refill the propane every time it goes out. They have a natural gas source. A lot of the generators these days come with Wi-Fi capability, so they're going to be able to have maintenance alerts, so they can send on your phone. You can have a connection to this thing. You can do remote monitoring, so through your phone you can see what's going on with it. It does firmware updates. It does any kind of data logging of like historicals and what's been going on with it. But if it needs maintenance or anything like that, that's the reason for the Wi-Fi. So making sure that it has a Wi-Fi connection is really good thing. But that's the gist of like the generator. Now between the transfer switch and the generator, we're going to have to run some wires. So we're going to have to run low voltage wires. So not only do you have to pull power out of here and run the power conductors to the panel to actually like energize the panel, but you're gonna have to run low voltage conductors in between them as well. If we look at the low voltage side, we're gonna have 6 conductors generally. Again, it kind of depends on the generator, the manufacturer, but in this situation, don't pay attention to the colors. The colors don't really matter. I just picked 6 colors, but typically you're gonna have a block on the generator that matches the block on the transfer switch, and it's gonna say 12 VDC plus, 12 VDC negative. So you have your plus and minus for your DC power for the car battery. You're gonna have a ground, you're gonna have a transfer signal. It's a signaling wire that signals the transfer from utility power to generator power. And then you're gonna have your sensing conductors. So you're gonna have 2 conductors, basically one per phase, that is sensing utility power. And when that goes out, that's what signals the relay to switch over and start this thing and actually start the power transfer. A lot of times you'll have a neutral as well. In the install that you're about to see, they did not have a neutral on the transfer switch side, but they had a neutral on the generator side. So if you need to have a neutral for your installation, if the control logic or if the schematic calls for you to have a neutral in order for those relays and for that control to actually happen, for the transfer to happen, then you will have to run a neutral. You might have a 7th conductor that you have to worry about, but a lot of times you really don't need that. But that's pretty much the gist of it. So like how it's supposed to function then, knowing that we have a transfer switch and a generator, and we have low voltage wires between them, and we have power wires that are coming back to feed the panel, is in the transfer switch, this thing opens and closes. So during utility power, it's just gonna act like nothing's there. It's just like this thing doesn't even exist. It's just sending power through like your normal service would work to your panel and your house works. If utility power is lost, this thing's gonna flip automatically. The sensing wires are gonna cause this thing, the relay, to switch which position it's in, and boom. Now the wires that are coming off the generator are feeding inside the transfer switch and feeding the panel, feeding your entire load. And it will keep doing that until its fuel source is completely depleted, and then you're just kind of out of luck. There is charging in here for the battery, so as the generator itself is running, it's charging with the generator power, and then when it's switched back to utility power, can recharge that battery as well. That's part of the signaling wires that go between the two. So that's the gist of how it works though. You lose power and boom, the generator starts running everything. Now there's a different way that you can set this up. If you don't want the whole house to be on it, you can install a separate little sub panel. And this is actually a popular idea because it means you don't have to reconstruct the entire service to get your whole house on this. You could just have a small critical loads panel, like a little 12 circuit panel that you run specific loads to. And in this case, what I would do is still put a transfer switch in a little sub panel somewhere. It could be in a basement somewhere. It can be kind of wherever's convenient near a panel, because what you're gonna have to do is tear a couple of these circuits out. So pick a couple lighting circuits throughout the house, pick a couple receptacle circuits, maybe a microwave, some things that'll like keep you going if power is out for, especially for like 3-4 days. You want to be able to function and live less comfortably than you would if there was power on, but like just to be able to basically cook yourself some food, to like use the bathroom, to sit around, charge some phones, you know, like if TV for some reason is working, like, you know, just think very minimally, because you have few circuits that you can run off of it. But you're going to take those circuits off here, you're going to put them in this panel instead, and you're going to hook the transfer switch up, so when utility power is working, it's just feeding everything in this panel as well as feeding everything in this panel. So since those lights and plugs aren't in here anymore, they're coming out of here. So both panels are now working. The only difference is when you lose utility power, the transfer switch again does what it's supposed to do. It transfers to which source, and the generator kicks on, and the generator feeds only the loads that are in that critical panel. So everything else in the main panel is dead. That's the benefit of having one of these. The other benefit is that you could power this off of just a breaker. You could hook a breaker up, run smaller wire to this transfer switch, and you know, the same size wires over the sub panel. So you could feed like a 60 amp sub panel on some number 6 and a 60 amp breaker. That's a much cheaper way of getting a generator to have some backup loads than having to reconstruct your entire service, you know, just to feed the entire home. So those are two different options though. I figured, you know, there's different use cases, and a lot of people don't realize that you don't have to do the entire home. You can do the whole home, or you can just do specific loads that you want to. Now for the fun part, the actual installation. So before we get into the nuts and bolts of the installation, there are a few things that you have to consider before you even just go start hooking up conductors. and that is your fuel source. So every generator is going to need a fuel source. It's going to either need like a propane tank that's dug in underground or a propane tank installed somewhere that you're going to pipe in fuel into this thing, because just like a car, a motor, it kind of works the same. Motors and generators are inverses of each other, but you still have to provide fuel for it to pull that fuel for the combustion for it to work. So you can either have a refillable kind of fuel source, or if you have like natural gas on your property like these guys did, you can just hook into your natural gas system, and that way you don't have to refill anything. The next thing to consider is the generator location. So some things that I've run into in the past are if there is a homeowners association in the neighborhood. Generators are loud, and some people consider them unsightly. And when I say they're loud, they're like really, really loud. So you might have restrictions on where this thing can go, and trying to plan out where your easiest conduit run is to like actually get the conductors into the transfer switch. That's one thing to think about, but also like bushes to hide the thing, you know, where it's going to go is a really important thing to know. Now, another thing to consider is the space around the generator itself. It needs to breathe. It's a really hot piece of equipment, and people need to work on it. So you need to make sure that there's ample space around it. With Generac, they recommend that on the sides and front that you have 36 inches of clearance all the way around it. So, you know, from the exhaust, it can actually ventilate out. You're not going to burn anything nearby, but it at least has enough air to breathe. And then on the inlet side in the back where the air intake comes in, they want an 18-inch space left. So again, it can just draw in all the air that it needs. The next thing is, are you going to do a whole home backup where you're feeding your entire home, all the circuits in it, or are you just going to have a little sub panel that you're feeding that just has some critical loads in it? Like I said before, if you're doing a whole home, you're going to have to rebuild your service, and you're going to have to re-pipe things from utility, pull the meter, you know, like it's a really involved process to do it this way, but you only have one panel, and everything in that panel within reason can be run. The other method, installing critical loads, is super easy. You just pull some circuits out of your panel, put them in a critical loads panel instead, and then you just pipe to the transfer switch and then connect the two, so it just transfers over to only those critical loads. In this case, that is what we're doing. So Generac was nice enough to send out a generator and a transfer switch, so thank you, Generac, for doing this. But in this case, they have a 22 kW generator, and 22 kW, that's a monster. Like, that could run this entire house, and especially since they don't really have any electric appliances, everything's gas. But in this case, they just decided, let's just do a critical load panel, and we will run off of just those things, so we're not like pulling too much. And they got 4 kids, so like they might have like tons of people trying to do a bunch of stuff, so it's better to keep things limited in certain limitations so that they're operating comfortably during an outage, but they're not like, you know, balling out of control, like trying to do everything under the sun. Then the next thing to consider is, where is the sub panel that you're going to be pulling these loads out of? All 4 of these questions are really, really crucial to know. So when you go out to a job and you start asking questions, these 4 questions are crucial, because the homeowner might not have even thought of any of this stuff. And if you go in and install something and then the HOA gets upset and you got to come out and redo it all. So it's really important just to answer those 4 questions. Once you have those answered, it's time to rip. All right, so now that you're like ready to install this thing, first things first, you need to set the generator. So in this situation, we have natural gas. We have our first question answered. We already know what that's coming in. Then the next thing is, with it in place, make sure that the fuel source gets piped into it, that it's left off until the startup procedures are ready, where you're gonna have to turn it on and actually feed the gas in there. The location of the generator was also super convenient. They kind of had this concrete area, this little pad, and it happened to be right next to their natural gas line, so they were able to easily put that in, and it allowed for a pretty much a straight run through the basement to where the panel was. After the generator is installed, one other thing to consider is these things have Wi-Fi in them. So if you don't have a signal for your Wi-Fi for it to be able to go through its automated procedures when it starts up, you might need to get a booster, or you might need to get like some kind of mesh network, something installed so that that generator can hook up to your Wi-Fi system, because if it can't, you can still manually operate without a lot of this stuff. It's just that you're not going to get a lot of the firmware updates and things like that. So it's really smart to just have it on Wi-Fi and make sure you have a strong enough signal so when you go start it up, it'll actually read the Wi-Fi. The next thing answered for us is we knew where the panel was. It was in the basement. So it's not really a sub panel, it's the main panel, but their meter is up outside in the backyard, and they just have a little LB that goes down right below it into the basement into their main panel. And so there was plenty of space next to it to just build a big piece of plywood and mount the transfer switch and the critical loads panel right to that. And then all they had to do was pipe circuits from one panel to the other panel, and it was really close by. Now that we got the generator installed and piped in, and we know that there's good Wi-Fi in the area, the next thing to do is set the transfer switch and the critical loads panels. So like I said, we had a big piece of wood, we installed all of that stuff, and it was ready to go. The next thing was just to run conduit in between them. So when you're running conduits, just remember you're gonna have power that's going between the transfer switch and the generator. So you probably, you might need like 1 inch, inch and a quarter, depends on the size of the generator and all that. If you're doing 100 amps, like running 100 amp wire, because that's what the generator is going to be powering your 100 amp transfer switch with. The second conduit could be like a 1/2 inch or a 3/4. It's just going to be some 6 conductor, low voltage cable that you're going to be running out to hook up as the signaling wires for this thing to signal the transfer automatically. Next is the wire pull. So obviously you got your conduit in place, pulling in the conductors, whatever conductors you decide to feed. You know, if you have a 100 amp transfer switch, if you have a 200 amp transfer switch, there's all kinds of different sizes of these, but just make sure that you're using the National Electrical Code to decide what kind of conductors you're running to this thing and base it off of what type of loads you're going to be running. And then when you're done with that, pull the low voltage conductor all the way from the transfer switch to the generator. So now you have power conductors from the transfer switch to the generator, and you have your low voltage. Now, some of you may have caught this, but some of you may have not. There is a code violation. If you look really close at the bottom of this transfer switch, they've got their neutrals and grounds all put together on the same bus, on a neutral bus, not on a ground bus. Is this okay? This is a separately derived system, right? So we're deriving power from a new source, not utility, like most solar or even transformers, because there's complete 100% isolation in a transformer from the primary to the secondary. We consider the secondary outward as a new source, so a separately derived system. Well, in a lot of transfer switches, you have either neutrals that can be switched or neutrals that are not switched. And if you have neutrals that are completely continuous, meaning you have a neutral coming in from utility, landing on the neutral bus, and then you got the generator's neutral coming in and they're bolted together, there's never separation there. So it's not technically considered a separately derived system. Then how we ground and bond this whole thing has to be different. So when you have neutrals that are completely isolated, it's okay that you use that piece of equipment, that transfer switch, as your service disconnect, because this is a service rated piece of equipment. So they're saying this could be considered your first disconnecting means on the premises if you wanted to use it this way. However, the neutrals have to be switchable for you to be able to do that. So for you to take all your grounds, neutrals, everything, bond them together, put your grounding electrode down into the ground from this point, this one singular point, you have to switch the neutrals. But if your neutrals are not switched, then you have a continuous neutral from the utility to the transfer switch out to the generator, then you cannot connect the neutrals and the ground in this enclosure. You have to keep them isolated the entire way. So they had to go back and change this, but the grounding electrode that's at the service, that needs to be our singular point where our main bonding jumper, all of our equipment grounding conductors, our neutrals, all of that stuff is connected at one point. And because this is not a separately derived system and we don't have isolation of our neutral, all of that has to stay at the service. That means we need to continue the separation that we've done everywhere else in the building and keep our grounds separate and our neutrals separate. So adding a ground bus to this, landing all the grounds on it, and then keeping that isolated neutral bus with only neutrals on it is the right way to do this. So it was fixed. I just wanted to take the time to talk about that because I think that's a really important thing. So check out 250.30 when you're bored if you want to read more about grounding and bonding for separately derived systems, or in this case, not separately derived systems. Next thing to do is just land your wires. Land them on both sides. Everything's pretty easy. Use the user's manual if you have to figure out which terminals are which. Once you get into an automatic transfer switch, understanding, if there's a breaker on the top, does the breaker get fed from the generator, or does the breaker feed your critical loads panel? There's always two sets of incoming conductors for the two power sources. There's going to be your utility in and the generator in, and then there's usually a separate area, typically with a breaker on it, that is going to feed the actual panel that you're feeding. So you don't have to have a critical loads panel that has a breaker in it if your transfer switch has a breaker in it. If it doesn't for some reason, well, it wouldn't, but if it didn't, you would have to have an actual breaker at that panel, because you have to protect those conductors somehow. Then just hook up all the low voltage terminations. These are pretty easy in the instruction manuals. You're always gonna have these 6 things labeled. You're gonna have your battery plus and minus, you're gonna have your transfer conductor, you're gonna have the 2 signaling or monitoring utility wires that are monitoring each phase, you're gonna have a ground. So hook all of those things up, and then the terminations on this are all pretty much done. Then make sure you put a breaker in the panel. In this instance, right, we're not doing a whole home thing. We're just coming off the panel with a breaker to feed 100 amps from utility, and then we've got the generator feeding 100 amps in when the utility goes down, so it's a 100 amp wire the whole way. Once you get everything hooked up, there is an instruction manual that comes with these generators, because the startup procedures are actually pretty important to follow. A lot of the newer generators like this model, they have a little screen on them and it walks you through all these different prompts, and there's an automated sort of way that you can do this. If it can already hook up to Wi-Fi signal and you go online and register and set everything up ahead of time, then it will naturally just set itself up. You'll still have to put in some information like the date and time zone, and if you want to have any kind of a startup schedule so that it starts up and does like maintenance cycles. But go through the instructions, because it actually tells you screen by screen what buttons to push to make sure the thing is set up how you want it to be set up. Then once everything's ready, you go through the startup procedures. So that involves first just starting the generator, and this is where you turn your fuel source on, make sure you're actually bringing fuel into it. Make sure that if there's any breakers or overload protection or anything like that, that you turn these switches on so that it will actually start up. A lot of times when people can't get startup to happen, it's either because they don't have the fuel source actually in the right position connected, they don't have the right type of fuel source inside selected. So there's a little selector that says, are you natural gas or are you propane? Make sure that's selected as well. Make sure that your battery terminals are hooked up, because a lot of times you'll get a signal too that's like, hey, we don't have AC power, this thing's not being fed, we don't have charging for the battery. So a lot of the little errors happen right on startup, but once you actually give it AC power and it's got Wi-Fi and you have all of these, fuel source, everything turned on the way that it should be, you're gonna start that generator up. And in the instructions, it'll tell you for how long. Typically the first startup, you're gonna let it run for 5 minutes. Just get up to speed, and this is how you would test it, and then you shut it off. And then the next thing you do is you put it under load. So you start it up and you actually add some loads to it to see how it functions under load. Meanwhile, the whole time you're doing this, you need to make sure that you have a multimeter that can test frequency, because this generator is putting out an AC signal. So you need to make sure that you're actually getting 60 hertz AC, or all of your appliances and everything you have hooked up to this could get all messed up, or they start acting really weird and not running right. So make sure that you have 60 hertz and that you have a way to test frequency. I had a Fluke T6 1000, and that thing had a frequency. A couple of the meters that I have frequency on them. So make sure that you have a meter that can detect frequency. Don't forget this part. But you also want to take voltage measurements. So like when this thing starts up and it actually starts to send power over, before you hook anything up to it, you need to make sure that you've got good voltage coming in on those conductors. Before you connect it to any loads, make sure, check the voltage that's incoming into that transfer switch from the generator, and that you're checking the frequency at which it's coming in. If those things are really good, turn on some loads and start adding loads to it, and then mark down how everything's working. It recommends that you mark your fuel pressure. You got to monitor a lot of things with this just during startup to make sure everything's within parameters. And then the last thing, if under load everything worked fine, now you have to test the automatic transfer feature. So putting the generator into maybe a standby mode, kind of depends on the model of it, but getting it to automate its own transfer by putting it in an automatic state where it knows automatically I'm supposed to work like I'm supposed to work. You cut utility power, you go shut the breaker off that's feeding the transfer switch, and that simulates a power loss. And when that happens, it will trigger a sequence from the generator to, over a certain amount of time, maybe like 5 seconds, 15 seconds, something like that, it'll start the generator, and that generator will run for a little bit, it'll get up to speed, and then the transfer will happen, and you'll hear that transfer switch transfer over, and it transfers power in, and now everything's running off the generator. And the next thing you do when you're in that automatic mode is you re-energize even when it's feeding utility power in. I know that's kind of scary because it's like, well, wait, I don't want to like energize this and bring utility power in when I've already got generator power coming in. It has a functionality where it can detect first and then act second. So with the generator running and everything's running just fine, you can re-energize that panel, turn the breaker back on, send the utility power back on. The generator's just going to keep running and nothing bad's going to happen. And it's going to sit there, it'll monitor, it'll signal, okay, everything's good, and it will shut off the generator and transfer the power back over to utility. So it automatically takes care of this whole process, but you have to make sure that you're starting the thing up and testing it no load, starting it up, testing it with load, and then starting it and testing it and making sure that it'll follow through with its automatic procedures. Always read the instructions because there are certain cases where if you miss steps in the setup, it won't do its automatic standby function. It won't monitor the power, or it'll monitor it, but it won't actually change over when you lose power. So you might think that this thing is set up correctly and it's actually not finished being set up, so it's not going to run through its procedures. So that's really it though. That's the whole thing. I know that was complex. Maybe you need to like watch this again because there was a lot of steps, but in all reality, it's very, very simple. So just remember the 4 questions ahead of time. That's a super, super important part of all of this. Don't just go slap a generator in and then not think about anything beforehand. Really think about like, okay, location, HOA, neighbors, loud, where's the panel, what kind of fuel source is going in. Once I know where the panel is and if I'm putting critical load on or if I'm doing a whole home thing, then you can proceed with your install. So, hope you guys learned something. Love you crazy people. I'll see you in the next one.